All right, so what we were doing last time was working in section 5.3. And I'm about to show you today how advantageous your calculator can really be with this stuff. We were looking for the zeros of a particular polynomial. And so we were looking at the possible rational zeros, called the rational root theorem, listing out all the possible zeros, and then using those in synthetic division to be able to factor a polynomial. So let's go to where we left off last time, which was right here. Problem number 2. And so I want to talk about the directions on this one. F of x is equal to x cubed plus 3x squared minus 6x minus 8. I want you to factor this polynomial over its, obviously, its zeros, roots, x-intercepts. But the first thing you should do before you can factor a polynomial, and that's what I'm asking you to do, here's a polynomial, factor it. First thing you should do is part A, I want you to list all possible rational zeros. How many people have taken the pre-section stuff to section 5.3 and watched the awesome video? I did a lot of examples on that thing, so thank you. Take notes off that guy. It's a little long, but the key to it is the number of examples I did to try to make this stuff easy for you guys. So the first thing you want to do is, and this is exactly what we're doing on your pre-section quiz, what we're doing in class. First thing you got to do is list all possible rational zeros. You start with a0, the constant term. What's the constant term on this problem? -8. And you list all the factors. These are called the p's. What are the things that divide into -8? Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. An is the leading coefficient. What is the leading coefficient of my polynomial up here? It's understood to be 1. It's the coefficient of the x cubed. We don't write 1, but it's implied that it's there. 1. What are the factors of 1? That's nice. It's plus or minus 1. So the list of all possible rational zeros is any way you can take a p and divide by a q. Well, since the leading coefficient is 1, this is really nice. It's all these p numbers divided by 1, which is pretty much all these p numbers. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. How many possible rational zeros are there? 8 of them. 1, 2, 3, 4, but the plus or minus gives me 8. How many zeros at most does this polynomial have? 3, the degree of the polynomial. So, I asked you the question last time, do you feel lucky? Start guessing. Pick a number, -4, and let's see if it's going to work. And the way you check to see if it's going to work is you do synthetic division on -4, and if it works, if it's a 0, you should get a remainder of 0. But if you had to guess all day long on this problem, you guys are poor guessers. I've seen your multiple choice part of the test here. So based upon that, I say let's don't guess. What I want you to do is graph the function. So go up here and clear out the old graphs, and here's the trick. And it's not in any book anywhere. I'm trying to tell you guys an easy way to how to do this thing. Take this polynomial, x cubed, type it in, plus 3x squared minus 6x minus 8. Make sure you type it in correctly. And I'm just going to do a zoom standard, zoom 10, -10 by 10, -10 by 10 screen. My picture may or may not be on my screen, but all I really care about is the places where the graph crosses the x-axis. Where does this graph cross the x-axis at? -4, -1, and 2. I just found all the zeros. And let's see, is -4, 2, and 0, -4, -1, and 2 in my list here? Sure is. But using a calculator doesn't show me any work. I'm showing you here's a calculator. It's going to tell you where the answers are if you graph it. But now here you go show your work. We're not going to guess. I know what one of my zeros are. And I always use the biggest one because I'm going to use synthetic division to try to reduce this polynomial. Let me show you. I'm going to choose -4. Okay? If it's a 0, I'll have a remainder of 0 when I do synthetic division. So using my calculator, I'm going to take and try -4. The synthetic division uses the coefficient of my terms in my polynomial in decreasing order. My coefficients are 1, 3, -6, and -8. There are no terms missing in this thing. So it's 1, 3, -6, and -8. Skip a line, draw a line. How do you do synthetic division? You bring down your first number, and below the number line, below the line, you multiply. -4 times 1 is -4. Above the line, you add. 3 minus 4 is -1. Below the line, you multiply. -4 times -1 is +4. Above the line, you add. -6 plus 4 is -2. Below the line, multiply. -4 times -2 is +8. And then above the line, you add. -8 plus 8 is 0. And always block off the last term because this guy is your remainder. And what a surprise, what kind of remainder do I get? 0. So that tells me that I have a 0 of -4. What is the factor? If the -4 is the 0, called C, what's the factor? X minus C, or in this case, X minus -4, which cleans up to be what? X plus 4. There's my factor. The resultant polynomial, called the quotient, is down here below. Remember, you build this up because he's going to be a degree less. This was your remainder. This is your constant term, X squared term. This is how you build it. This was the original constant term, X squared, and have one more term. This was the X cubed term. You always start at the back and work your way forward in terms of variables. So what is my quotient answer to this problem? It was what? X squared minus X minus 2. Therefore, understand this. My original polynomial was X cubed plus 3X squared minus 6X minus 8. I now can tell you the polynomial is going to factor into, this was my divisor, X plus 4, from the -4 being the 0, times the quotient. The quotient from the synthetic division is down here. It is X squared minus X minus 2. This is how my polynomial factored. There was no remainder, so it's plus 0. But it gets better. What kind of polynomial do you have as your quotient? It's a quadratic. And in quadratics, you can either find 0 with the quadratic formula, or you pray and hope you can factor the darn thing. How does this guy factor? So now you can continue on and get the answer in factored form. This is X plus 4 times. Now how does X squared minus X minus 2 factor? X squared factors in X and X. What times what is 2? That differ by 1. 2 and 1, and because the middle term is minus, the bigger number is going to be minus, and the smaller number is going to be plus. Does that make sense? Which means that the other factors are X minus 2 and X plus 1, and now automatically you get what as the zeros. If X minus 2 is a is a factor, what's the 0? 2. And if X plus 1 is a factor, the 0 was -1. And if you go back and check your calculator, where did it cross the x-axis at? -4, -1, and 2. -1 and 2 besides -4. And most important, you factored the polynomial, which is what they wanted you to do. Yes, ma'am.
On the homework for the quiz for 5.2.
3 through 2, okay?
It said to check if a certain number was a 0 of a polynomial.
Yes.
And then if it wasn't, enter.
Enter the remaining value, the remainder theorem. So f of the remainder would have been the value. So how to check to see if a number is a 0 to a polynomial, and that goes back to chapter 5.2, it's the synthetic division stuff. You take that number and you synthetically divide it into the polynomial, or you could also, it's called the remainder theorem, you could plug that number into the polynomial. And the result you get when plugging into the polynomial, or the resultant you get when you take do the synthetic division, is the remainder. The remainder and the functional value are the same thing. That's called the remainder and the remainder theorem. Try this one here. Same directions. I want you to take this polynomial, x to the fourth minus 2x cubed minus 5x squared plus 8x plus 4, and I want you to factor it. I want you to factor it in a certain way. First thing I want you to do is part A. I want you to list all possible rational zeros. So, what's my constant term? What's A0? 4. What's my p's? What are the factors of 4? Plus or minus 1, plus or minus 2, plus or minus 4. What's an equal to in this problem? Well, the leading coefficient is a 1 again. So q are the factors of 1, which is plus or minus 1. So to list all possible rational zeros, you're supposed to list every possible way you can write a p over a q. Luckily, once again, q is plus or minus 1, which means I'm going to take all these numbers and divide by plus or minus 1, which pretty much gives me all my numbers. Plus or minus 1, plus or minus 2, plus or minus 4. Does that make sense? How many possible rational zeros do I have written up here? 6. 3 of them plus or minus make 6. How many zeros at most does this polynomial have? At most it has 4. So let's see if it's going to be one of these numbers. So instead of guessing and trying to plug and chug and guess through synthetic division, I'm going to use my calculator to help me out here. Let's graph it by doing x to the fourth minus 2x cubed minus 5x to the fifth, 4, 3, 2. When there's no term missing, if there's a term missing, don't forget you got to put 0 in for it. 5x squared plus 8x plus 4. And then I'm going to do zoom 6 on it, and I'm going to graph it. And again, the graph's going to be all over the place, and maybe off the screen or whatever, but I want to find my zeros. Okay? Do you see any zeros? I got -2. I got some kind of interesting fraction there. I'll have to go back and investigate that. And it looks like maybe +2. It's hard to see on this calculator. This is a great example. I'm pretty sure about -2. You see that one? So that's the first one I'm going to start with. Thanks to my calculator, -2 is one of my lists. I'm going to try -2. And I'm going to do synthetic division. And remember, if there's a term missing, don't forget to put a 0 in for it. So my coefficients are 1, -2, -5, 8, and 4. 4, 3, 2, 1 constant. Here we go. Skip a line, draw a line. Bring down your first victim, 1. Multiply. This will be -2 times 1, which is -2. Add, I get -4. -2 times -4 is 8. Add, I get 3. -2 times 3 is -6. Add, I'm going to get 2. -2 times +2 is a -4. I add, and guess what I get? 0. Which tells me, because I got a remainder of 0, which I was hoping for and expected kind of on the calculator, I've got my zeros. I got one of them anyway. It's -2. What factor did it come from? Remember, C is a 0, x minus C is a factor. This will be x minus -2, which makes the factor x plus 2. But I'm trying to reduce this polynomial down to a quadratic. What is my resultant, my remainder of this synthetic division? This one is constant x squared, x cubed. I haven't got him down to a quadratic yet. I've got him down to x plus 2 times 1x cubed minus 4x squared plus 3x plus 2. So I'm going to go try to find another 0 and do synthetic division on this one. 1, always use the reduced part. 1, -4, 3, 2. Now, look at your calculator, look at your graph. Do you think you got another number? And remember, it's got to be in your list. This is why we do the list first. I'm thinking positive 2 right here. Does that make sense? So let's go with positive 2. Now let's see if it works. If it doesn't work, you'll know it because you won't get a remainder of 0. So skip a line, draw a line. Bring your first victim down, 1. Multiply 2 times 1 is 2. Add negative 4 plus 2 is negative 2. Below the line, multiply 2 times negative 2 is negative 4. Add 3 minus 4 is negative 1. Multiply 2 times negative 1 is negative 2. Add, I get 0. 2 was a 0 in this thing. It was hard to tell. I was hoping it looked like it crossed there, but I would have to zoom in on it and all that good stuff. All right, so I've got 2 is a 0. What does that make the factor? X minus 2. So right now, you've got the polynomial down to this. Because what's resulted down here is constant x, x squared. You got him down to the quadratic. But watch what happens. Therefore, the original polynomial, f of x, which was x to the 4th minus 2x cubed minus 5x squared plus 8x plus 4, factors into what? We did 2 reductions on this thing because this was a 4th degree polynomial to get it down to the quadratic. My 2 factors are x plus 2 times x minus 2 times what's left? Very good. X squared minus 2x minus 1. Does that make sense? I lose you guys anywhere. But we want to factor this in terms of linear factor. So, with linear factors, here's the deal. Take this particular quadratic. To figure out the other zeros, you set that quadratic right there equal to 0. So I'm going to put him down here. He is x squared minus 2x minus 1. Set him equal to 0 and solve. Your problem is this. This quadratic doesn't factor. Very good. X, what times what is 1? That adds up to be negative 2. Well, with a minus there, there's my problem. It doesn't factor. Does not factor. But don't worry, we have it all memorized. It's kind of a requirement to pass the class here. We have the quadratic formula. What is the quadratic formula? Sing along if you know it. Negative b plus or minus square root b squared minus 4ac all over 2a. In this particular problem, a was equal to 1, b is equal to negative 2, and c equals negative 1. Does that make sense? So here we go. This would be equal to negative b, negative 2, negative 2, plus or minus the square root of b, negative 2 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. Watch the arithmetic, and let me blow it up so you guys can see it in the back there. Clean it up. What's a negative 2? And be careful. This is where people make their careless errors at. Negative 2 is what? Positive 2. Plus or minus the square root of, what's negative 2 quantity squared? 4. What is negative 4 times 1 times negative 1? Positive 4. Negative 4 times 1 times a positive 4. The sign goes with it. It's positive 4. All over 2. Keep cleaning them up. What's 4 plus 4? So it's 2 plus or minus the square root of 8 over 2. Good time review for the old final exam here. Let's clean up the square root of 8. How can you clean up the square root of 8? Very good. The square root of 8 is the same thing as the square root of 4 times 2. But the square root of 4 is what? 2, so I can pull a 2 out. So this is 2 plus or minus 2 square roots of 2 over 2. And I want to clean them up some more because I'm trying to get that fancy looking answer to this thing. Because I have a single denominator, I can bust them up. This will be 2 over 2 plus or minus 2 square roots of 2 over 2. You take single denominators and put it in each term in the numerator. What's 2 divided by 2? So x is equal to 1 plus or minus, the 2's here cancel, square root of 2. How many zeros do you see in this thing? There are 2 of them. What are my 2 zeros? X is equal to 1 plus the square root of 2, and x is equal to 1 minus the square root of 2. Does that make sense? So, these are my 2 zeros. Let's go back up here. I have a 0 of 1 plus the square root of 2, and the other 0 is 1 minus the square root of 2. These are irrational zeros. You can't write these guys as fractions. They're irrational. They always show up in the quadratic formula, and they always show up as conjugate pairs here. 1 plus the square root of 2 and 1 minus the square root of 2. But if these are my zeros, what are my factors? It is x minus 1 plus the square root of 2. When you clean it up, that gives you x minus 1 minus the square root of 2. And the other factor is x minus 1 minus the square root of 2. When you distribute the negative, that gives you x minus 1 plus the square root of 2. So these are my 4 factors. Remember, it was a degree 4 polynomial, so at most I had 4 factors. So what is my resultant answer? How does this polynomial factor? F of x is equal to x plus 2 times x minus 2 times this guy factors into x minus 1 minus the square root of 2 times x minus 1 plus the square root of 2. That is the resultant answer. You find the nice zeros, and then the not so nice zeros will be, you'll discover those with the quadratic formula. You get your zeros, remember your factors are x minus the 0 numbers. Does that make sense? It's not hard. It is detailed and technical and convoluted in that sense, but I'm doing the same thing, but most important, I'm trying to get it down to that quadratic. And my calculator is a godsend because it's not going to allow me to just... In the old days, before calculators, we had to guess at these numbers, and hopefully we ran across a 0 when we got the remainder 0. Thanks to the use of the calculator, I can actually get the zeros without having to do so much guesswork. Yes, ma'am?
So if we were putting this in like online,
Yeah.
would we put like the little, because it didn't ask for the whole equation, it just asked for the zero. So would we put?
Okay, so again, I'm trying to prepare you for the cumulative departmental final exam thing here, and of course my next test. So on the Hawk system, when they just ask for the zeros, you would type in -2, comma, +2, comma, 1 plus square root 2, comma, 1 minus square root 2, comma. That's just the zeros. But this is how it's written in factored form, which is another way we can ask you the question. Take the polynomial and factor it over its zeros. So they're really connected. The intermediate value theorem states this. If for a polynomial f of x, f of a and f of b have different signs, aka one is positive, one is negative. So if I plug in a number and I get a positive value for a y coordinate, and I plug in another number, I get a negative value for a y coordinate, then f of x has a 0 at a point between f of a and f of b. This is a great way of trying to zero in on where your zeros are at. This is what the intermediate value theorem states. If you plot a point A and you got some negative coordinate, and you plot B and you got some kind of positive coordinate, and it's a continuous function like a polynomial, you've got to connect the 2 dots. And the only way to connect the 2 dots is you're going to have to cross the x-axis. And when you cross the x-axis, you got a 0, a root, an x-intercept. That's what the intermediate value theorem says. So, an example of this. Show the following polynomial has a 0 between 1 and 2. How do I show it has a 0 between 1 and 2? I'm not going to go find the 0. It didn't say find the 0. It says show that there exists a 0 between 1 and 2. Well, this is how you do it. It's the intermediate value theorem. And we're math people, so we have to abbreviate everything. The IVT, intermediate value theorem. Here it is. I'm going to do f of 1. Pick one of my coordinates and plug it in. This would be 1 to the 5th minus 1 cubed minus 1. Well, we can do that. 1 to the 5th is 1. 1 cubed is 1. 1 minus 1 is 0. Minus 1 is negative 1. Notice I get a negative value. And let's do the other point, f of 2. This would be 2 to the 5th minus 2 cubed minus 1. 2 to the 5th is 2 times 2 times 2 times 2 times 2, which is 32. Minus 2 cubed, 2 times 2 times 2, what's that? 8 minus 1. 32 minus 8, what's that? 24 minus 1 is 23. But, don't care what the number is, what sign of it? It's a positive 23. So I plotted 2 points. You want a visual? I'll give you a visual. Here it is. Here's 1, and here's 2. When I plot f of 1, I got negative 1. When I plot 2, I got the y-coordinate 23. Now, f of x is a polynomial, x to the 5th minus x cubed minus 1. It is a continuous function, which means I got to connect these two dots. How are you going to connect the two dots? Some kind of a line. What do you notice? You cross the x-axis, which means there's a 0. There exists a 0 between 1 and 2 by the intermediate value theorem. Yeah, we proved it. That's all this theorem states. It allows me to get a handle on between what values is my 0 going to be. So if I plot one point, I get negative values. I plot another point, I get a positive value. I know between those 2 points there had to be a 0 between them. Chapter 6.1. Chapter 6.1 is rational functions and rational inequalities. Now, we have been playing with all through chapter 5 there, we've been playing with polynomials. You know, x to the n plus a sub n x to the n plus a n minus 1 x to the n minus 1 plus dot 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 plus x1 a1x plus a0. But what a rational function is a polynomial divided by a polynomial. And that's what they're saying here. A rational function is a function in the form of f of x equals p of x over q of x, where you have the p of x polynomial divided by the q of x polynomial, and q of x, the denominator, can't be equal to 0, because you'll violate rules of math if you divide by 0. So, and the domain of a function is all real numbers except where the denominator equals 0. So all real numbers where the denominator doesn't equal 0. And that's what they're saying here. So, take a look at this guy here. M of x is equal to 2 divided by x minus 1. Question is, what's the domain? What kind of numbers can I plug into M of x here? That's what we ask. We ask for the domain. We traditionally want the answer in interval notation. But it's a division problem. And when it comes to division, you got a problem. You can't divide by what? 0. So to find this problem, you take your denominator and you make sure it's not 0. So solve. I'm going to add 1 to both sides. X can't be equal to 1. Does that make sense? So by domain in English would be, domain is all real numbers except 1. All real numbers except 1. But how do I write that in the mathematical computer system, the way they're going to want it on the final exam? How do I write all real numbers except 1 in interval notation? Interval notation. Parentheses, negative infinity. 1, open parentheses, union, open parentheses, 1 to infinity. This is how you would write it. You got to skip over 1. So you use that big old union symbol through your little keypad thing there. Does that make sense? All real numbers except 1. What about number 2 here? What is the domain? Now I know this can kind of cancel and stuff, but I don't care. The question is about domain. The fact is, I have a denominator here. You could factor it if you wanted to. It's x plus 6 divided by, how does x squared minus 36 factor? X plus 6 times x minus 6. Now you're right, the x minus 6 is canceled. And we talked about this before when we were talking about vertical asymptotes. So let me talk about that for just a second to remind you. A vertical asymptote versus a hole in the graph. To find vertical asymptotes, you set the denominator equal to 0 because those are where your problem points are at and they create these vertical lines in your graph. But when you factor your denominator and the factor cancels, you don't get vertical asymptotes, you get holes in the graph. If the factor of the denominator does not cancel, you get vertical asymptotes for that factor. So in this problem, what do you notice? The x plus 6's would cancel. You with me? That would tell me that there is a hole when x plus 6 equals 0, which means there's a hole when x equals negative 6. The factor that cancels, you set it equal to 0 and solve x equals negative 6, that would be a hole in the graph. The factor that does not cancel, x minus 6, would be your vertical asymptote. X minus 6 equals 0, add 6 to both sides, x equals 6 is where your vertical asymptote is going to be at. Okay? But the question on this one isn't about vertical asymptotes versus hole in the graph. The question is about domain. We'll get into those restricted hole stuff, and I've got it, we talked about it before, and I've got it written properly for you right here, what I just said here. But the question still is this: what's the domain? To find the domain, you do the same thing every time. I don't care if the terms cancel or don't cancel. You take the denominator, set it equal to 0 and solve, and you omit that from all real numbers. So the domain. The factor was x squared minus 36, which does factor into x plus 6 times x minus 6. We're going to set it equal to 0 and solve. X plus 6 equals 0, x minus 6 equals 0. I get x equals negative 6, and x equals positive 6. These are my problem points. These are the guys that I officially cannot have. X cannot be negative 6. X cannot be positive 6. That would make me divide by 0. So, I ask you again, in interval notation, what is the domain? You can read it in English, it's all real numbers except negative 6 and positive 6, but I want it in interval notation. What would it be? Negative infinity, negative 6, union, keep going. Negative 6 to positive 6, another union, 6 to infinity. You get all the segments except you got to skip over negative 6 and you skip over positive 6. That's the domain. Yes, ma'am.
Would it kind of be the same if you just originally set x squared minus 36 equal to 0 and just did like x could equal plus or minus 6 and you have to...
Well, I'm doing it the factor way because it kind of leads us back to what we did in the last section about factoring polynomials. But you're right. I could factor it, or if you wanted me to, I could solve for x squared by adding 36 to both sides. But then I would have to take the square root to solve for x. But when you introduce the square root, you have to do the plus or minus. Yeah, we get the same answer. But make sure you do the plus or minus when you do the square root. You'll get the same answer. Asymptotes. An asymptote is an imaginary line that a graph of a function approaches as a function approaches a restricted number in the domain or as it approaches infinity. It could be positive infinity or negative infinity. Vertical asymptotes. Wholes. Factor the numerator and the denominator completely. In terms of that they appear if both the numerator and denominator equal to 0 and solve. Those values that are wholes, those values of x that are wholes of the function. Now, this is a badly worded way of explaining it, but what we're talking about here is you factor the numerator and denominator completely. And any factors that are the same, let me put it in here. Any factors that are the same set equal to 0, and there is where the holes in graph occur. The numerator and denominator, if they got the same factors, like in this problem here, x plus 6 over x plus 6, these guys would have canceled. So I would have taken the x plus 6 factor, set it equal to 0, and there's a hole at negative 6. Okay? The vertical asymptote is where the denominator that does not factor, you set that equal to 0. If you turn the page, that's what I talk about here in this definition. If p of x over q of x is a rational function, p of x and q of x have no common factors. That was the trick right there. And n is a 0 of q of x, then the line x equals n is a vertical asymptote of the graph. It's the no common factor terms. The factor terms that don't cancel, set those equal to 0, and that's where you get your vertical asymptotes. Now, what happens at a vertical asymptote? In other words, y increases without bound as x approaches n. So as you get very, very close to these vertical asymptotes, you're either going to blow up to infinity or blow down to negative infinity. All right. So, take a look at this guy here. For the following rational functions, find the holes and the vertical asymptotes. I want you to be able to see the difference between where a hole is at versus a vertical asymptote. This one, factor your numerator. Well, you just got 2. Factor your denominator, x minus 1. Does x minus 1 cancel? No. So as x minus 1 doesn't cancel, there are no holes. You set the factor x minus 1 equal to 0, solve for x equals 1. This is your VA, vertical asymptote. There are no holes, vertical asymptote. Take a look at the next guy. They went ahead and factored it for me. That was mighty nice. I've got 2x squared divided by x minus 2 times x plus 6. Does anything cancel? Do you see factors canceling? No. So because of that, there are no holes because nothing cancels. However, the vertical asymptote, you set the factor x minus 2 times x plus 6. You just set the rest of the denominator equal to 0. Set each factor equal to 0. And you solve. X equals 2. And x equals negative 6. Subtract 6 from both sides and just add 2 to both sides there. These are this one has 2 vertical asymptotes. However, take a look at number 3. I've got x plus 8 divided by x squared minus 64. You can factor that denominator. That's x plus 8 divided by, what's x squared minus 64? How does that factor? X plus 8 times x minus 8. I see some canceling going on here. So in terms of holes, I take the factor that cancels, the x plus 8, I set it equal to 0 and I solve. X equals negative 8. That's where there's going to be a hole in the graph. Where x equals negative 8, if you analyze that, there'll be a hole in the graph at that point. The other factor is the vertical asymptote. The factor that does not cancel, which is x minus 8, you set it equal to 0 and solve for x. You get x equals positive 8. That is the vertical asymptote. Take a look at your next example. H of x is equal to x plus 8 divided by x squared plus 64. How do I find a vertical asymptote? Well, I got to factor the denominator. Well, I'm just going to take the denominator and just go ahead and set it equal to 0 and see if I can factor it and see if I can figure out what's going on here and see if it factors with the x plus 8. But how would you set x squared plus 64 equal to 0? How would you solve for x? Because it's a plus, it doesn't factor. Minuses is called a difference of squares. X, x minus a times x plus a stuff here. X squared plus 64 is not a difference of squares. So to solve this thing, we're going to go back to the traditional method. Solve for the x squared. I would subtract 64 from both sides. That gives me x squared equals negative 64. Now what kills off a square? Square roots. You take the square root of both sides, and don't forget you got to introduce the plus or minus on this thing. And I get x is equal to plus or minus the square root of negative 64, which is what? What's the square root of negative 64? Why does not exist? It can't take the square root or an even root of a negative number. So in other words, there are no vertical asymptotes on this guy because the denominator, when you try to set it equal 0, doesn't exist. So you don't have any problem points. So your domain of this problem is actually all real numbers. Does that make sense? So watch this type of stuff where you're trying to violate some rule of math. Remember, you can't take the square root or an even root of a negative number. These are your horizontal asymptotes versus holes in the graph. The other type of asymptote is called a horizontal or an oblique asymptotes. So this theorem is going to come back and haunt you, especially for you guys that are moving on into calculus, that want to take calculus next semester. You're going to see this dude again. Given the rational function, f of x is equal to p of x over q of x, which is this x sub n, a sub n x to the n plus a n minus 1 x to n minus 1 all the way down to a0, divided by b sub n x to the m, b sub m x to the n plus b to the n minus 1 x to the n minus 1 all the way down to b0. Got polynomial over polynomial. If n is less than m, then y equals 0 is the horizontal asymptote. Who in the world is m and who in the world is n? Let me put it in English for you. N is equal to the degree of the top polynomial. M is equal to the degree of the bottom polynomial. So we're talking about the degree of the top versus the degree of the bottom. So in other words, when the degree of the top is less than the degree of the bottom, you get y equals 0 as the horizontal asymptote. So it's an analyzing and memorizing theorem here. When the degree of the top is less than the degree of the bottom, y equals 0. When n equals m, or in other words, the degree of the top is actually equal to the degree of the bottom, you get y equals the ratio of the leading coefficients, a sub n over b sub m. Y equals the ratio of leading coefficients. The AN over BM, the ratio of leading coefficients. And, well, there's only one other case, and that last case is this. If, and there's a typo here, if N is greater than M, N fell off for some strange reason. If N is greater than M, there are no horizontal asymptotes. But there's something called a slant or oblique asymptote. Okay? So when the degree of the top is greater than the degree of the bottom, there are no horizontal asymptotes. You get something called a slant asymptote. And you get slant asymptotes by doing long division, and y equals the quotient is your slant asymptote. Y equals the quotient when you do long division is your slant asymptote. Quotient after long division is the slant / oblique asymptote. This is how you get it. You get this y equals the quotient when you do your long division. So, here we go. Let's see if you guys have that quick memorization thing of getting this stuff down. Degree of the top versus degree of the bottom. Degree of the top is less degree of the bottom, y equals 0. When the degree of the top equals degree of the bottom, the answer is the y equals the ratio of leading coefficients. When the degree of the top is greater than the degree of the bottom, you get something called an oblique slant asymptote, which we'll talk about more down here. Okay. So here we go. Look at the following rational functions. Find the horizontal asymptotes, if any. All we're interested in horizontal asymptotes on this one. We'll get to slants later. What is the degree of the top? 1. What is the degree of the bottom? 2. Degree of the top is less degree of the bottom. What is the horizontal asymptote? And it's an equation. Y equals 0. It's 0, but you always state that y equals 0. Vertical asymptotes are x equals. Horizontal asymptotes are y equals. Okay? Here, g of x equals 5x cubed over 3x squared plus 1. What is the degree of the top? Degree of the top. 3. What is the degree of the bottom, the denominator? 2. When the degree of the top is greater than the degree of the bottom, what is your horizontal asymptote? Y equals none. No horizontal asymptote. You have something called a slant asymptote. We'll talk about that in a second. The question is, what's the horizontal asymptote? It's none. 0, empty set if you want to use the old Hawk system. All right, let's try this one. H of x is equal to negative 3x plus 7 divided by 5x minus 2. What is the degree of the top? 1. What is the degree of the bottom? 1. What is the horizontal asymptote? Y equals what? Very good. It's the ratio of the leading coefficients. The leading coefficients is negative 3 over 5. The answer is y equals negative 3. Look at number 4. Y equals 2x minus x squared divided by 2x squared minus 2x minus 3. They try to write this stuff out of order, but be careful. What is the degree of the top? 2. It's that term right there. What is the degree of the bottom? 2. They're the same. So what is your horizontal asymptote? Y equals the ratio of the leading coefficients. But remember, leading coefficients are the coefficients attached to the degree term. What is my ratio of my leading coefficients? Very good. This is implied negative 1 over 2. Negative 1/2. Does that make sense? I lose you guys anywhere. All right. Oblique asymptotes. Given the rational function that f of x equals p of x over q of x, where of course p of x is a sub n, x of n, plus a sub n minus 1, x to n minus 1, plus da da upon a0. And q of x is equal to b sub m, x to the m, plus bm minus 1, x to n minus 1, all the way down to b0. If n is equal to m plus 1, and I did try to type this stuff in English, the degree of the top is greater than the degree of the bottom, then do long division and you're going to get this function. Q of x, p of x divided by q of x is equal to the quotient plus the remainder over the divisor. Then y equals the quotient, this is what I was telling you guys, is the oblique asymptote. So on this particular example, the degree of the top is 3. The degree of the bottom is 2. The degree of the top is bigger than the degree of the bottom. Therefore, this thing has a oblique asymptote. What will it be? Well, here's a good time to practice your long division. What's my quotient? It is 3x squared. What's my divisor? 3x squared plus 0x plus 1. Remember, if there's a term missing, put a 0 in for it. What is the dividend? What's the big one? 15x cubed plus 0x squared plus 0x plus 0. Bunch of terms missing. Don't forget to put 0 in for them when you do long division. Every term has to be accounted for. Okay? So, let's play the division game. What times 3x squared equals 15x cubed? Well, what times 3 is 15? 5. What times x squared is x cubed? X. So, 5x times 3x squared is 15x cubed. Now distribute. 5x times 3x squared is 15x cubed. 5x times 0x is 0x squared. 5 times 0 is 0. X times x is x squared. 5x times 1 is 5x. What am I going to do now based upon long division and all the stuff you guys have memorized? Subtract, changes your signs. This will be a minus, this now is a minus, this now is a minus. First term should always cancel. 0x squared minus 0x squared is 0, that also cancels. I'm left with 0x minus 5x, which is negative 5x, plus 0. Now play the game all over again. What times 3x squared is negative 5x? Well, x squared doesn't go into x. Does that make sense? Since it doesn't go into x, what do you call this dude? You can stop because you found the remainder. But the question is, what is the oblique or slant asymptote? It's y equals, and it's the quotient. What was the quotient in the long division that we just played with? 5x. The answer is y equals 5x, the quotient. Does that make sense? This is how you find slant asymptotes. And you ask yourself, what's the point of all this stuff? Well, it tells you what's going on at infinity and negative infinity. Let me show you. Look at the graph here of this graph. 15x cubed divided by parentheses 3x squared plus 1. I'm going to do a zoom 6 and just do a negative 10 by 10 screen here. There's my graph. Okay? And you got some weird stuff going on in the middle. But what is the oblique asymptote? If I go over here under y equals and just graph 5x, it's not the same in the middle. You got this little blip here, but 5x, as x gets bigger and bigger and bigger, these two lines get very close to each other. Basically, this function turns into this function as x goes to infinity and x goes to negative infinity. That's what the slant or oblique asymptotes do. That's actually what all asymptotes do. If you look at this one right here, let's do this one, the bigger polynomial. It was parentheses around your numerator, 2x minus x squared, close parentheses, divided by 2x squared minus 2x minus 3. If I do a zoom 6 on this thing looks like this, and it has a couple of asymptotes in it. Let me slide it over, you guys can see a little better there. Okay? And I got some asymptotes in it, but it does this. What was the horizontal asymptote in this problem? Y equals what? Negative 1/2. If I go to y equals and just type in negative 0.5, negative 1/2, it's a line right there that goes through. And if I kind of zoom in on this thing, change my window between, let's see here, negative 0.4 and negative 0.6, and just graph it. Oh, I screwed up the window there. Let's try that again. Negative minimum, I got it backwards. Negative 0.6 and negative 0.4. Sorry, put them backwards. I got this guy here. Whoop, 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 I messed up. Hold on. Negative 10 to positive 10. These are supposed to be y numbers. Oh, sorry. Try negative 0.6 to negative 0.4. All right, so this is between negative 25 and positive 25. So you got all this stuff going on in the middle. But if you look at x gets close to positive 25, negative 25, this is the line as x approaches infinity and x approaches negative infinity. what the graph goes towards. So the horizontal asymptote tells you what's going on when x gets really big, infinity, or really small, negative infinity. That's what's going on. This is what this graph approaches this number there. Because you know what we're after here. We're after you graphing these guys, not just using your calculator. All right, but of course, we're going to double check ourselves on our calculator, but we got to be able to get the answer without a calculator. So, graphing rational functions. Here are your 8 steps to glory, or they anticipate you guys doing, to graph a rational function. Factor the denominator to determine the domain. First off, find the domain. 2, factor the numerator and reduce any common factors. That means you're looking for holes in the graph and vertical asymptotes. So determine the vertical asymptotes, and then part number 4, also determine any oblique asymptotes or horizontal asymptotes. But he wanted you to always plot a couple of nice points. So always find the x-intercept and the y-intercept. Y-intercept, plug in x to 0. X-intercept, set it equal to 0. Decide if there's any symmetry that's going to help you out with this graph. And then plot any extra points that you need to plot on this thing, and then connect your dots. This is the game plan on how to graph a rational function. So, here we go. I got a function here. F of x is equal to 3x squared divided by x squared minus 4. Step 1, there's steps. 1, what's the domain of this function? Well, the domain is this. It's a rational function. I don't care if it cancels or not. Take the denominator, set it equal to 0, and solve it. What's my denominator? X squared minus 4. Set it equal to 0 and solve. But you know, x squared minus 4 factors. How does x squared minus 4 factor? X plus 2 times x minus 2 equal to 0. Set each factor equals 0. X plus 2 equals 0. And x minus 2 equals 0. That gives me 2 answers. X equals negative 2 and x equals positive 2. So my domain is negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. All real numbers except negative 2 and positive 2. But this is the way we want the computer to write it out, and the way they're going to make you want to write it out on the final exam. Hence, it'll be like my next test. Negative infinity to negative 2, negative 2 to 2, and then from 2 to positive infinity. All right, so number 2, we're going to factor that polynomial. F of x equals 3x squared over x squared minus 4, which factors into 3x squared over x plus 2 times x minus 2. Let's talk about holes versus vertical asymptotes. Do you have any holes in this graph? How do you know? None of my factors, I factor numerator, but there's nothing to factor here. None of my factors cancel. None of my x plus 2 doesn't cancel. The x minus 2 doesn't cancel. Does that make sense? So there are no holes. None. What about vertical asymptotes? Well, you just set the denominator, x plus 2 equal to 0, and x minus 2 equal to 0. That gives me x equals negative 2 and x equals 2. Those are my vertical asymptotes. X equals 2 and x equals negative 2. There are 2 of them. Okay? So while we're at it, let's go ahead and start the process of graphing this thing. Because that's part 8, is to graph it. So every time you discover something or other, write it down. What is my vertical asymptote? Negative 2, x is negative 2, and x is positive 2. So vertical asymptotes are these vertical dotted lines that you cannot cross. You can cross horizontal lines, you can't cross vertical lines. X equals 2, x equals negative 2. Vertical asymptotes. Lines in the sand that I can't cross. Let's keep going. All right, so we've done number 3, we factored it, number 2, and this is number 3, we look for holes in vertical asymptotes. 4, Let's talk about horizontal asymptotes. Let's go back to the original problem. F of x equals 3x squared over x squared minus 4. What is the degree of the top? 2. What is the degree of the bottom? What do you notice? They're equal to each other. So therefore, according to the theorem that we have memorized, what is the horizontal asymptote? Y is equal to what? The ratio of leading coefficients. Officially 3 divided by, understood to be 1. 3 over 1, which is y equals 3. Let's draw that in there. Y equals 3. 1, 2, 3, there's 3. I'll make a horizontal dotted line right there at 3. Y equals 3, and at infinity and negative infinity, this is what the graph approaches. It just tells me what's going on. Doesn't tell me what's in the middle, it tells me about the ends. Number 5. Tell me what the y-intercept is. Remember, my function is f of x is equal to 3x squared divided by x squared minus 4. How do you find a y-intercept? You plug in x as 0. So this would be f of 0, which is 3 times 0 squared over 0 squared minus 4. That's pretty much 0 divided by negative 4. 0 on top is 0. So I have a point, 0, 0. And I'm going to plot. That's my y-intercept. It also happens to be my x-intercept. But I'm going to get that from number 6. What is the x-intercept? Just to do the practice. X-intercept, what do? You set y equal to 0. So I get 0 equals 3x squared over x squared minus 4. How do you solve for x? When you've got 0 equals 3x squared divided by x squared minus 4, what do? I got to get rid of fractions. You're solving. You always want to get rid of fractions. So what's my first move? Multiply both sides by x squared minus 4. This is going to give me, what's 0 times anybody? 0 equals, here it cancels. Okay, x squared minus 4 is canceled. I'm over 3x squared. Now, solve for x. I'm going to divide by 3. That gives me 0 equals x squared. Take the square root of both sides, officially plus or minus, but who cares? What's the square root of 0? 0. So I get x equals 0, which tells me I get the same point again. 0, 0. Does that make sense? Now, number 7 says about symmetry. If you had any. F of x is equal to 3x squared divided by x squared minus 4. 3x squared is even. X squared minus 4 is even. Even divided by even. It's even. This is an even or symmetric with respect to the y-axis. Notice this. Note. F of negative x would be equal to 3 times negative x squared over negative x squared minus 4. See, all this stuff we've done before come back to haunt you. What's negative x quantity squared? It's negative 1 squared. Positive 1. So this is 3x squared. And negative 1 squared is 1. That goes away, x squared minus 4, which is the original function. This is considered to be an even function or symmetric with respect to the y-axis. Just keep that in mind, that the y-axis is going to split this thing down the middle. But the most important step besides finding the vertical and horizontal asymptotes on this rational function is this last step. Last step, number 8, is you need to plot points if necessary. This is step number 8. You're not just plotting a bunch of points, you're going to plot some special points. Which special points do you want to plot? You always want to plot a point on either side of a vertical asymptote, and you want to plot one down the road on your horizontal asymptote on either side. So I'm not plotting a bunch of points. Look, I've got -2 here. I'm gonna plot a point on either side of my vertical asymptote. I'm gonna plot -3, I'm gonna plot -1. I'm gonna plot +1, I'm gonna plot 3. And then I'm gonna plot a point down here someplace. And so, go down the road a little bit, here's 4, 5, 6 is good. I'm gonna plot 6, here's -4, -5, -6. I'm gonna plot -6. These are the only points I'm gonna plot, but they're strategically located based upon my graph. One point always on either side of a vertical asymptote. Because you can't cross a vertical asymptote. So you gotta know what direction you're going. Is it gonna blow up or is it gonna blow down? So remember, your original function, which is this. F of x is equal to 3x squared divided by x squared minus 4. So I'm gonna plot points. Here we go. Plugging in -3. This will be 3 times -3 squared divided by parentheses, another parentheses, -3 squared minus 4. Notice the wonderful use of parentheses that I typed in on this thing. Always parentheses around your numerator, parentheses around your denominator. Especially when you got multiple terms, parentheses around your denominator. What do I get? And I'm going to plot it. It's 5.4. All I need to know is the general location. Now I'm going to plot -1. So I'm going to call it back down with my second entry and change all those -3s to -1s. What do I get when I plug in -1? I get -1. Plug in +1. So change all those -1s, delete the negative and make them +1s. I still get -1. What a surprise. Symmetry's helping me out here and I'm seeing it. Now I'm going to plug in 3. I get 5.4. And now I'm going to plot 6, and then I'm going to plot -6. Last 2 points. 6, plugging in 6 into my function, I get 3.375, and now I'm going to plug in -6 by calling it back down and inserting a negative. And I get the same thing because of symmetry, 3.75. So, I plotted these points. Let's plot them out. -3, 5.4. 3, 4, 5, 6, 5.4 would be right about there. -1, I get, when x is -1, I get -1. So -1 would be here. 1, I get -1. 3, I get 5.4 right up here. 6, I get 3.75. Here's 3, 3.75 is just above it. -6, I also get a -3.75. Yeah, positive 3.75. But now, remember this. When you're graphing, you start a graph from left to right. The horizontal asymptote tells you what you're getting very, very close to on the horizontal line. Start there. But all my points are above it. So my graph will be above it. I connect my dots, but I cannot cross a vertical asymptote. So I've either got to blow up or blow down. As I approach this number, what direction are my points going? So they're going up, so my graph has got to go up. You got to go with the pattern. You can't cross a vertical asymptote. So on the other side of the vertical asymptote, you see the point right here. Is he located up or down? He's down compared to the other points. So this would have been going down on this side. Connect my dots. And as I approach my vertical asymptote again, I got to go in the direction that my points take me. I'm going back down. As I cross over my vertical asymptote, I either blow up or blow down. Since my points are up, they must have blown up. And then I connect my dots. And as I approach 6 and stuff, I've got to go towards my horizontal asymptote. But the last thing you want to do to this graph is this. Put it on your calculator. Now I'm going to do something special on my calculator. Let me show you. Y equals clear out the old one there, clear out the old stuff. Parentheses around the numerator, 3x squared, close parentheses. Divided by parentheses around the denominator, x squared minus 4. But I'm checking to see if my graph is correct or not. So hit the window button and change it to your window. I'm going between -6 and +6. And I'm going down here, which is, here's -1, -2, -3, -4. Something down here, I'll probably about a -8. Y minimum is -8 to +8. And now graph it, and you should see the exact picture that I drew. And the exact picture that I drew, it matches up, so I know I got the right track. Practice this stuff. This is not trivial stuff. And we'll finish up these next problems next time. And I just graphed it right there, so we'll start with these guys next time. See you guys then.